In this chapter, the following topics are discussed: naming monoatomic and polyatomic ions, naming and writing formulas for ionic compounds, naming and writing formulas for molecular compounds, naming and writing formulas for acids and bases, the laws of definite and multiple proportions. How are ions named? A monoatomic ion is an ion consisting of a single atom with a positive or negative charge. The charge results from the loss or gain of one or more valence electrons. The table below shows ion symbols for some group elements. Metallic elements tend to lose valence electrons to form cations with a positive charge equal to their group number. Nonmetals tend to gain electrons to form anions, with a negative charge equal to 8 minus the group number. Note: the majority of elements in group 4A do not form ions. It would require them to lose or gain 4 electrons. Group 8A elements, also known as noble gases, do not form ions either because they have a completely filled outer electron shell, making them extremely stable. Some metallic elements form more than one cation with different ionic charges. When naming cations using the stock system, the charge on the ion is shown by a Roman number in parenthesis after the name of the element. This is the preferred method of naming cations. A polyatomic ion is composed of more than one atom. In the table shown, some common polyatomic ions are shown. The names of most polyatomic anions end in ite, like in sulfite, or ate, like in sulfate. The ite ending indicates one less oxygen atom than the ate ending. When a polyatomic ion begins with H, the H represents a hydrogen ion combined with another polyatomic ion. The charge on the new ion is the sum of the ionic charges of the ions that combine. For example, hydrogen carbonate ion is a combination of hydrogen ion and carbonate ion. Let's have a look at binary ionic compounds, which are composed of 2 elements. Example: potassium chloride is an ionic compound consisting of potassium cations and chloride anions. Since the net charge of the formula unit has to be 0, we need to balance the charges so that the positive charge of the cations balances the negative charge of the anions. The table below lists 3 binary ionic compounds. The first one is potassium chloride. The positive charge of the potassium cation is balanced by the negative charge of the chloride ion, so potassium chloride combines in a 1-to-1 ratio. Iron 3 oxide consists of iron 3 cations and oxide anions. To balance the charge, you need to find the common multiple of 3 and 2, which is 6. You need 2 iron 3 cations for a positive charge of 6 and you need 3 oxide anions for a negative charge of 6. So, iron 3 oxide combines in a ratio of 2 iron 3 cations to 2 oxide anions. The procedure to write the formula for compounds with polyatomic ions is very similar to the one used for binary ionic compounds. First, write the symbol or formula for the cation followed by the symbol or formula for the anion. Then add subscripts needed to balance the charges. To name a compound containing a polyatomic ion, first write the cation name and the anion name. In the table below, you can find some examples for compounds with polyatomic ions. A different approach is used to name and write formulas for molecular compounds. Prefixes are used in the names of binary molecular compounds to indicate the number of each kind of atom. Refer to the table for a list of prefixes to use. Note: mono is not used for the first element. As an example, compare how to name carbon monoxide and carbon dioxide. To write the chemical formula if you know that name is rather straightforward. Example: what is the formula for nitrogen trifluoride? The name shows that each molecule has 1 nitrogen atom and 3 fluorine atoms. How to name and write formulas for acids and bases. An acid is a compound that contains at least 1 hydrogen atom and produces hydrogen ions when dissolved in water. A base is a compound that produces hydroxide ions when dissolved in water. The general formula for an acid is HNX, where X is an anion, and N indicates the number of hydrogen atoms. The naming depends on the name of the anion, X. If you know the name of an acid, you can write its formula, after balancing the charges. Here are some rules for acids. If the anion name ends in IDE, then the acid name begins with hydro. If the anion name ends in ITE, then the acid name is the stem of the anion with the suffix OUS, followed by the word acid. If the anion name ends in ATE, then the acid name is the stem of the anion with the suffix IC, followed by the word acid. Bases are named following the rules for ionic compounds. The name of the cation is followed by the name of the anion. To write the formula for a base, first write the symbol for the cation followed by the formula for the hydroxide ion, then balance the ionic charges. Example: sodium hydroxide, NaOH, is made up of sodium cations and hydroxide anions. The law of definite proportions and the law of multiple proportions describe how elements combine to form compounds. The law of definite proportions states that in samples of any chemical compound, the masses of the elements are always in the same proportions. In magnesium sulfide, the magnesium to sulfide mass ratio does not change, despite the mass of the sample. The law of multiple proportions states that, if two elements form more than one compound, the different masses of one element that combine with the same mass of the other element are in the ratio of small whole numbers. Example: copper and chlorine can form two different compounds, copper 1 chloride, which is a green ionic solid, and copper 2 chloride, which is a blue ionic solid. For any given mass of copper, there is always twice the mass of chloride in copper 2 chloride, as there is in copper 1 chloride.